So in this question, we have different small scenarios on investment appraisal to understand the basics of net present value, discounting, and the concept of time value of money. We will be using the cost of capital of 14%, which could be assumed as an interest rate, but we have discussed cost of capital before. It's a lot more than simply inflation and interest rates. What you need to do, if you haven't looked at present value tables and annuity tables before, then I would recommend that you go back and understand the present value tables, annuity tables before watching this video. Let's look at the first question. How much will an investment made now of 1,000 be worth in 7 years' time? So the question we need to understand is, if we leave £1,000 in an investment in a bank or in a business, and every year we are getting return of 14%. This return could be interest or this could be profit of 14%, and we leave the principal and the return on that. We don't withdraw anything. How much would that be worth? Now this question is on compound interest, how the compound interest works. So let's solve this situation. So we have £1,000 invested, and the cost of capital is 14%. So every year it will become 114%, and 114% is written as 1.14, because 100% is 1, and then 14% is 0.14. Now what's going to happen, every year we're going to get some money, some interest on that. So what we do, we power the brackets by the number of years, and in this case it's 7. Basically we are going to get the compound interest on this amount for 7 years. So let's see what we get. Now putting the proper formula now, 1,000 into 1.14 power sign and times 7, and you press enter, that would be 2502. We don't need that decimal places. Let's go back to our question now. Second one, what is the present value of 2,500 receivable in 7 years' time? This question is reverse of the first question. In first question, we were depositing 1,000 for 7 years, and we received 2,502. So we can assume it's 2,500. And in the second one, we are being asked that if we receive £2,500 now, in 7 years' time, sorry, not now, what is the value now? So it should be 1,000, but because the cost of capital in both cases is same. So let's see, what do we get? Number 2, what are we going to do? We're going to receive £2,500 in 7 years' time. So all we need to do is multiply £2,500 with the value of £1 received after 7 years under 14% cost of capital. So going back to our present value table, not the annuity table, the present value table, under 14% for 7 years, if you go there, you will see a figure which is 0.400. So if you multiply 2,500 with 0.4, you get 1,000. So very similar. So small difference is there because of the decimal places. So we can ignore this difference. Otherwise, everything is same. Number 3. What is the present value of 600 receivable every year for the next 3 years? So this is an example of annuity. If you receive something regularly every year, same amount, it's called annuity. So how to answer this? Let's see. We have £600 coming up every year. We multiply this with the annuity factor for 3 years under 14%. So this time we are going to look at annuity table, not present value table. Under 14% for 3 years, we have 2.322. Under 14% for 3 years, 2.322. So 600 times 2.322. Number 4, an investment of 400 now would allow me to draw every year for the next 9 years. How much? So the question is that if you want to have a regular income, let's say of 1,000 or 2,000 or whatever, this question actually helps us to understand that how much we need to deposit now to have a regular income. So let's go to Excel. For we are withdrawing, we are depositing £400, and what we need to do, we need to divide £400 with our annuity factor for 9 years under 14%. So 9 years is the timeline. 4.946, 4.946. Again, you can pause the video and check it on your table. So let's do this again. 400 divided by 4.946. Press enter and we get £81. So we can withdraw £81 every year if we deposit £400. So using the same logic, if you want to inverse this, we can actually find out that if we want a certain amount of money every year, how much do we need to deposit now? So if you do the opposite of this, if you multiply 81, so I want £81 every year, and the cost of capital is, let's say, 14%. So I will multiply this with 4.946, and I'll get 81 times 4.946 and £400. So this is the opposite. So this is very helpful when we are calculating pensions and fixed deposit contributions and stuff like that, which helps us to know how much we need to deposit at the start if you want to get a certain amount of money. Next question is number 5. What is the total present value of the following receipts? 1,000 every 5 years, so that's an annuity. Then 1,400 at the end of 6th year, so that's just one, so present value table, and 1,500 at the 7th year. What is happening? We are receiving 1,000 for 5 years every year, so that's an annuity. So looking at annuity factor for 5 years under 14%, we have 3.433. Then we have 1,400, and this is only 1 year, so we'll be looking at present value table under 6 years for 14%, 4.456, and then 1,500 after 7 years. So let's solve this now. 1,000 times 3.433, 1,400 times 0.456, and 1,500 times 400. So the total amount is sum of all these values, 4671.4. So that's the answer to 5. Now number 6. Number 6 says that I'm offered a lease costing 1,000 a year for the next 8 years. So I'll be paying 1,000 for the next 8 years. It will then be renewed at a further 2 years at a cost of 300 a year. So then I will be paying 300 for 2 consecutive years. What is the total cost in terms of present value? Okay, let's go to my Excel sheet now. So number 6. All right, so first what is happening, we are paying £1,000 for 8 years. So that is an annuity. 8 years under 14%. Annuity table, not present value, 4.639, 4.639. Then I'll be paying 300 in year 9 and 10. So 300, and I'll multiply that with the year 9 present value table under 14%. So 0.284, and 300 times 10 years value, 0.247. Let's solve these values now. 1000 times 4.639, 300 times 0.284, and 300 times 0.247. So to get the total expense of this lease for 10 years, I'll add this up. Number 7. Now these 3 examples are actually a full net present value table calculations on a very basic scale, but it incorporates all 4 factors of the NPV table, which is time, cash flow, discount factor, and present value. So we will do them one by one and choose between the 3 projects using 14% as cost of capital. So with NPV, the rule is if the project is positive NPV, we accept it. However, if you have more than one project, then we accept the project, or we choose the project which has the highest NPV. So basically that is the question in this case. So I'll take you to my Excel now and I'll solve all these 3 and then we will make a decision. We table time and cash flows. Now normally these things are given clearly in the question. What you need to do is to find out the discount factor. Let's write the whole thing. Discount factor at 14%, because the question says that 14%, and then present value. So when we multiply our discount factor with cash flow, we get present values. Okay, so timeline is 4 years for all of these projects. However, we always have a time 0. So 0, 1, 2, 3, 4. So actually these are 5 different instances on timeline. At the start, we invest money, we pay out. So it's a negative 9,500. And then we receive 1,000, 4,000 for the next 3 years, 4,000. So it seems like we are investing 9,500 and we are receiving £13,000 in cash terms. However, the real value, which is the present value, would be dependent on the discount factors. Now for time 0, value of £1 is always £1. And now what we will do, we will actually look at our present value table under 14% and look for the value of £1 under 14% after year 1. So that's 0.877, then 0.769, then 0.675, and the last one is 0.592. Okay, so let's multiply cash flows with discount factors. Obviously this is going to be the same because it's now, and I simply copy the formula and paste it there, so we get our present values. So 1,000 received after 1 year under cost of capital of 14%. We get present value as £877, and consecutively the values are 4,000, and you can see the 4,000 is losing value as we go further in timeline. We need to net these values now, so that's why it's called net present value. So present value, so what you do, you take positive and negatives together and you get a figure. So in this case, you can see that our net present value is negative. So we should reject this project. Even though it seemed like we're making a profit because we are getting £13,000, but the present value of those £13,000 is less than £9,500. Project Y. And we are investing same timeline, so I'll save myself some typing, and we are investing £9,750, so a bit more than project X, and we are receiving 3,000 in year 1, 5,000 in year 2, 5,000 in year 3, and then 1,000 in year 4. What are we getting? We're getting higher amounts now and lower amount at the end. This can have a positive impact on the NPV. Same discount factor, so let's just save us some time. Simply copy, Control C and paste. Because the same cost of capital. Again, multiplying our discount factor with our cash flows. One thing I forgot, that this should be negative, so let's put a negative there. And now copy the formula there, do the present value, and sum this up or net this up, because when you add positive and negatives together, you're actually netting off the figure, and this gives us a net present value of 693. So that is a positive figure. So how much we are receiving in money terms is 14,000. In project X we were receiving 13,000, so slightly more than that. Okay, next one, project Z. Let's steal the timeline, and we are investing 6750, so minus 6750, and then we are getting 3,000 every year. There we go. Same cost of capital again, so let's just copy it, and same multiplication. Same copy and paste the formula, and summing up the present values 1989. The present value is 1989. So we can see that we have 3 projects, and one is giving us a negative NPV, and the other 2 are giving us a positive NPV, However, we can see that the NPV which is being offered by project Z is a lot higher than project Y 1989. So we're receiving quite a lot of extra money there. We are receiving here £12,000, which is less than our received cash inflows in the previous projects, but our initial outflow is less, so that is making a lot of impact there. So we will choose project Z because it has the highest NPV. So